Hello learners, let us discuss landslide hazard zonation in this program. In fact, landslide hazard zonation refers to the division of the land in homogeneous areas or domain and their ranking according to the degrees of actual or potential hazards caused by the mass movement. Landslide hazard is commonly shown on maps which displays the spatial distribution of hazard classes in terms of landslide hazard zonation. Landslides failure have caused a number of casualties and huge economic losses. Economic losses due to landslides are apparently increasing as development expands in the hilly areas. In spite of improvements in recognition, prediction and mitigation measures, landslide activities are increasing. The factors causing the augmented activities are increased urbanization and development in the landslide prone areas, continued deforestation of landslide prone areas, and number 3, increased regional precipitation caused by changing climatic pattern. Identification of areas prone to landslide and their categorization are the key elements for suggesting mitigated measures for minimizing the losses caused by the landslides. Landslide prone areas are to be delineated on the maps by integrating multiple databases. When assessing the probabilities of landslide within an area, recognition of the conditions that cause the landslides and the processes that triggered the movement is of primary importance. It is well known that many factors play an important role in engineering slope failure. These thematic inputs which determine the probability of landslide in an area are grouped into two categories we may call as preparatory factors and the triggered factors. The preparatory factors are those which make the slope susceptible to failure such as geology of an area, structures, slope and aspects, relative relief, geomorphology, soil, drainage pattern and most important the land use and land cover. Whereas, the triggering factors are those which initiate failures such as rainfall or earthquake tremors. For the landslide hazard zonation maps, we need different thematic maps. These thematic maps are prepared from the topo sheet as well as from the when the data is collected. Well, from topo sheet we can prepare the base map, the drainage map and from the collateral data we prepare the landslide inventory map, soil map and socio-economic map. These maps must be checked with the selected ground truth techniques. There are other thematic maps which are prepared from the satellite imageries like geomorphology, land use and land cover and lineaments. Likewise, from radar set data image we prepare the digital elevation model that derives the slope and aspects. The landslide hazard zonation maps are prepared on 1:50,000 scale for regional planning, 1:10,000 scale for district level planning and 1:1000 scale for site specific micro zonation studies. These landslide hazard zonation maps may be made available to the concerned governmental and non-governmental agencies and users agencies for taking up necessary mitigation measures. Let us give you the example of landslide hazard zonation from a case study that I carried out in the Itanagar capital complex. The Itanagar capital complex is the capital of Arunachal Pradesh. See, we acquired the data from Survey of India and NRSA. See, topo sheet were acquired from Survey of India and the topo sheet 83 f by 9, 83 e by 12 and 83 e by 16 on 1:50,000 scale. And optical data was obtained in terms of IRS ID and list 3 digital data and IRS 1D pan digital data of a specific period. In this study, we used the IRS data of 4th January 2000, 30th October 2000 and 7th February 2001. In our study, we also used microwave data in terms of radar set image that is SAR Y2 of 14th June 2002 and SAR Standard 7 of 28 June 2002. Well, coming to the methodology, we adopt the methodology for this study, where we procure the topo sheet from the Survey of India and G-coded this topo sheet. We scanned the topo sheet and geocoded it and prepared the drainage map, from where we derived the drainage density and drainage frequency. At the same time, from the topo sheet we made the contours, and from this we generated the digital elevation model. From this we derived the different layers such as slope, shaded relief and aspect. Then we procured the raw images, that is active and passive remote sensing data from NRSA, and we geocoded the images. We merged the data of list 3 and PAN, and from this we derived the layers of lineament and land use land cover. From again lineament we prepared the lineament frequency, and we also studied the lineament density. Then third was the collateral data, which we collected from different sources. We scanned and geocoded it, and we made the landslide inventory map. With this prepared a layer of landslide inventory, and also from our this data we prepared the geological map, the soil map and geomorphology map. All these layers we analyzed under analytical hierarchy process for multi criteria modeling, and 2D maps were prepared, and finally we prepared 3D landslide hazards zonation map. Now, we show you some of the layers that we prepared. Now, this is the list 3 data of 7th February 2001 of Itanagar complex. First, we have defined the boundary of the Itanagar complex that made our study area. So, all the layers are within this defined boundary only. So, this is the list 3 data of 7th Feb 2001. Now, this is the PAN data of 7th February 2001, and then this is the SAR standard data of 14th June 2002. As I mentioned about different thematic maps, this is the thematic map of showing the contours. Here we have defined the contours different categories. Now, this is the digital elevation model that we prepared from this contour. This shows the slope, which is the different categories from 0 to 74 degree. Then slope is classified in different categories, that is less than 15 degree, then 15 to 30 degree, 30 to 40 degree, 40 to 50 degree and more than 50 degree. And we have defined how much area falls under which categories. Say for example, less than 15, it is 226.717. We have categorized into different categories, and accordingly we have defined the areas. Then we prepared the drainage map from Survey of India topo sheet. The map was subsequently updated using the satellite image, and the morphometric analysis for drainage was carried out, which has been described subsequently. So, this is the thematic map that we prepared showing the drainage pattern, and we derived the drainage density from this study. The drainage density in the area ranged from 0 to 6 kilometer per square kilometer, and the unclassified map is classified using reclassification technique into following classes, that is less than 2, 2 to 3 and 3 to 4 and more than 4 drains. So, with this the area comes to 60.861 square kilometer for less than 2 drains, and 2 to 3 drains come to 214.872 square kilometer. 3 to 4 drains comes to 169.563 square kilometer, and more than 4 comes 27.640 square kilometer. Then this is the drainage density map, which shows different categories of less than 2, 2 to 3, 3 to 4 and more than 4. Drainage frequency. Drainage frequency in the area range from 0 to 26 per square kilometer. The unclassified map is classified using reclassification techniques. As we can see here in this thematic map, the drainage frequency is less than 5, then 5 to 10, 10 to 15, 15 to 20 and more than 20. Then another thematic map is the land use and land cover. Here we can see the different categories, the sandy, the settlement areas, blue shows the river, yellow shows the agriculture area, gray color is the barren area and green color is the forest cover. Now, this is another land use land cover of 4th January 2000, earlier was of 7th February 2001, this is 4th January 2000 and then another one is 23rd November 1992. As you can see here, the sandy area, the blue, light blue is showing the settlement, deep blue is showing the river, yellow showing the agriculture area, gray showing the barren areas and green color shows the forest area. Now, this is the thematic map of change detection. That means, the land use land cover maps that we studied from 1992 to 2001, what are the changes have been taken place. As you can see here, that no changes in the riverbed, then the forest land has been mixed into the agriculture land and there are changes in the barren land in this area, then changes in the settlement and moderate forest has been converted into the dense forest area and most of these in the green color, green areas are the dense forest, there are still dense forests. However, the color is dark green which are the changes in this. So, this is the advantage of the thematic map, we can study the changes over a period of time. Well, next layer is the soil. The soil survey was carried out following standard techniques which involved the collection of baseline data, visual interpretation of images and ground truth correction. Based on the landform analysis map, soil combinations, final checking of unit boundaries and analytical data of soil, the soil map along with the soil agent was finalized. Geomorphology map is classified into high relief structured hills, low relief structured hills, low relief rugged hills, intermontane valley and Piedmont area. Now, this is the thematic map of the geomorphology, where different categories have been shown. Now, this is the geology of the area, where we have the quaternaries, the Kimin formation shown with the green color, Subansiri formation by the yellow color, Dafla hills with the blue color and Bombdilla group of rocks by the red color. Likewise, we can see the thrust and faults also in the area. Lineament map was prepared by visual interpretation from the satellite imagery and morphometric analysis of lineament was carried out, which has been described subsequently. Now, this is the lineament map and here we can see the different type of lineaments, that is major, semi major or minor lineaments. Then lineament density in the area range from 0 to 4 kilometer per square kilometer and the unclassified map is classified showing different categories, as we can see here less than 1, 1 to 2, 2 to 3 and more than 3 lineaments per square kilometer and the frequency map and the unclassified map is classified again. This is the thematic map showing the lineament frequency, where we have different 4 categories, less than 3 lineaments, then 3 to 6 lineaments, 6 to 9 lineaments and more than 9 lineaments. Likewise, we studied the lineament buffer zone also, because lineaments were divided into 3 categories on basis of their length, namely mega, major and minor, and buffer were made 300 meter for major lineaments, 200 meter for semi major and 100 meter buffer zone for minor lineaments respectively. As we can see here in this thematic map, another layer of landslide inventory, which shows the landslide inventory. And then when all the layers have been prepared, we gave weightage to each of the themes and we prepared this landslide hazard zonation map. This is the final output map, where it shows the highly susceptible areas, very high susceptible areas, moderate susceptible areas or least susceptible areas. In fact, everybody want to settle down in the urban town. Now, we can see a view of the Itanagar city, how people are coming out without considering the bearing capacity of the soil in that area. Dear learners, we learnt about the landslide hazard zonation in this program and how important these maps are for the planners. Thank you.